Let's practice evaluating numerical expressions together, and to do so, let's make sure we also follow the order of operations. For number 1, we have this numerical expression where we have 14 minus 2 to the third power plus 18 divided by 3 plus 4 times 5. So first we should think about using grouping symbols or parentheses, and we don't have any here, so we're going to move on to powers or exponents. Taking a look at this 2 to the third power, we want to go ahead and evaluate that. So remember, 2 to the third power is equal to 2 times 2 times 2. Now 2 times 2 is 4, and 4 times 2 is equal to 8. So that's what 2 to the third power, or 2 cubed, is. So if we go ahead and evaluate that, we're going to get 14 take away, and we just found that that's equal to 8, right? So we're just going to go ahead and copy down the rest of the problem, or the expression here. Go ahead and just do one step at a time, so we have all of these other parts that we have not done yet, okay? Okay, so we don't have parentheses, and we don't have any powers or exponents, so we're on to multiplication or division, whichever one we see from left to right. Looks like we do have a division problem and a multiplication problem. They're equally important. So we're going to go ahead and take care of the division problem because it comes first from left to right. So we have 14 minus 8. We're just going to copy that down. 18 divided by 3 is equal to 6. So we're going to go ahead and add 6, and then we're going to add the product of 4 and 5. At this point, between subtraction, addition, and multiplication does take priority here. So we're going to go ahead and multiply 4 times 5. So we're going to have 14 take away 8. We're going to add 6, and then we're going to add 20 here since 4 times 5 is equal to 20. Okay, so we're done with parentheses and powers and multiplication division. We're just left with addition and subtraction. Now they're equally important, so we're just going to work our way from left to right here. So 14 minus 8, that's going to equal 6. So we're going to have 6 plus 20. Then we can just keep going from left to right because we just have two addition problems. 6 plus 6 is 12. So we really have 12 plus 20. And then 12 plus 20, there's really only one step left to do here. So 12 plus 20, that's going to equal 32. So that's the value of this expression. And there we have our answer. Here's number 2. For number 2, we have this expression where we have 32 divided by the quantity of this 31 minus 3 cubed, or 3 to the third power. And then we're going to go ahead and add this 3 times 5. So we're going to start with parentheses, right? So we're going to take a look inside here. Now inside here, we actually have two things to take care of. We have subtraction and we have a power. Now between subtraction and a power, the power has to go first. So we're going to take care of this. Now on the side here, I'm going to say 3 to the third power, remember, is 3 times 3 times 3 if we expand it. 3 times 3 is going to equal 9, and then 9 times 3 equals 27. So 3 cubed is equal to 27. So we can go ahead and copy down this 32 divided by the quantity of, and this is going to be 31 take away 27. Keep that in the parentheses for now. And we're going to add the product of 3 and 5 together. Okay, so we did do parentheses, but we still have something to do inside here. So we're going to focus our attention on this parentheses. So 31 minus 27, that's equal to 4. So we're going to have 32 divided by 4. Then we're going to add the product of 3 and 5. So 3 times 5. So at this point, we have division, addition, and multiplication. Now division and multiplication are equally important, and they are more important than addition. So we're going to do the division first from left to right. 32 divided by 4 is 8. So we have 8 plus the product of 3 and 5. Now between addition and multiplication, multiplication is more important. So 3 times 5 is 15. So we're going to have 8 plus 15. Then 8 plus 15, that's going to equal 23. So that would be the value of this numerical expression. All right, so those first two practice problems had just positive numbers or whole numbers, and these next couple may have some negatives introduced or some negative integers, okay? So starting off here, it looks like we have -3 multiplied by the quantity of -5, take away 8, and then we're going to take away 4 cubed, or 4 to the third power, divided by 2 to the third power, or 2 cubed. Okay, so we do have a grouping symbol, so we're going to have to start off looking inside there. Okay, so this is -5 take away 8. That's where we're going to be focusing. Now keep in mind, if we are taking a -5 and we are taking away 8 on the side here, I'm just going to go ahead and write, if this helps, that -5 take away 8 is the same thing as -5 adding a -8. So that's going to equal -13 if we go ahead and add two negatives together. And so we can go ahead and write -3 multiplied by this -13. And then we're going to go ahead and take away 4 cubed and divide that by 2 cubed. Okay, so don't touch anything else yet. And so at this point, while you may look at this and say, okay, this looks like a grouping symbol, it's actually just showing that this is -3 multiplying by this -13. So even though it's parentheses, it actually just means multiplication and not a grouping symbol at this point. Okay, so we're going to move on from there. It looks like we have two different powers to evaluate. We have 4 cubed and 2 cubed. Okay, what we're going to do here is solve the one on the left first here. So 4 cubed. So 4 to the third power, or 4 cubed, is 4 times 4 times 4. Now 4 times 4 is 16, and 16 times 4 is 64. Okay, so let's go ahead and replace that or substitute it in. So we have -3 multiplied by -13 minus, and 4 cubed we just said was 64, and we're going to divide that by 2 cubed. Okay, so next we're going to have one more power that we're going to evaluate. So this is 2 cubed. Now we did this earlier, so I'm not going to go ahead and write out the work. That's going to equal 8. Feel free to write it out if you need to though. That's going to be -3 times -13 minus 64 divided by 8. Okay, at this point we have 3 operations. We have multiplication, subtraction, and division. Between those 3, we have multiplication and division, equally important. This multiplication happens to be to the left, so we're going to multiply that. A -3 times a -13 equals a +39. So we're going to go ahead and write 39 take away 64 divided by 8. Now between subtraction and division, division is more important, so we're going to go ahead and do 64 divided by 8. 64 divided by 8 is equal to 8, so we really have 39 minus 8. And 39 minus 8 is just one final step, and that's going to equal 31. So that's the value of this expression. Let's check out number 4. So for number 4, we have this expression where we have 7 minus 2, and 2 is being multiplied by the quantity of 5 minus 9 squared. And then we're going to take away 4 multiplied by this -6. So while we do have 2 sets of parentheses, keep in mind that the one on the right isn't actually a grouping symbol, it's just showing multiplication. So we're going to focus our attention over here on this subtraction problem. So that's going to be 5 minus 9. Okay. Now, hopefully subtraction of 2 positive numbers is getting a little bit easier. If 9 minus 5 is 4, then 5 minus 9 is going to be -4. So we're going to start there. So it's going to be 7 minus 2 multiplied by a -4 squared. And we're going to subtract 4 times -6. Okay. At this point, we have no more parentheses, but we do have a power or an exponent here. So we have this -4 squared. And so -4 in parentheses, and we raise that to the second power, that's going to be -4 multiplied by another -4. Now -4 times -4 is equal to +16, so that's what -4 squared is. We're going to go ahead and write 7 minus 2 multiplied by +16, that's what we just found out, minus 4 times this -6. Okay, so we have some subtraction here. We have a multiplication problem, a subtraction problem, and a multiplication problem. Since multiplication is more important, we're going to go ahead and take care of those. We'll go from left to right though. So 2 times 16 gets to go first. This is going to be 7 take away 32. 2 times 16 is 32, minus 4 multiplied by this -6. Next, we're going to go ahead and take care of the other multiplication problem. So this is going to be 7 minus 32. We're going to take away, and then 4 times -6 is equal to -24. So I'm going to write -24 in parentheses here. Okay, let's go ahead and take care of the subtraction problem, and there's 2 of them, so just do the one on the left here. 7 minus 32, if you just take 32 and take away 7, that's 25, so 7 minus 32 must be -25, so this is going to be -25. And instead of taking this subtracting a negative, we can keep change and flip this or add the opposite. So this would be -25, and we'd be adding a +24. That would be the same expression, or same value rather, and then -25 plus 24 is going to equal -1. That would be the value of this expression. All right, moving on to number 5. We're still going to follow the order of operations, but we now have some fractions or some rational numbers. So we have 3/4 minus 9/16 divided by 15/8 plus this -1/2 raised to the third power. Okay, so we actually don't have any grouping symbols in terms of grouping something, but we do have this parentheses showing that we have this -1/2 raised to the third power. So kind of coincidental here, but we are taking this -1/2 and cubing it. So that's going to be -1/2 to the third power. So that is a power, and that's going to get to go first here. So if we go ahead and think about what that's going to be, that's -1/2 raised to the third power, that's really negative 1/2 multiplied by negative 1/2 multiplied by negative 1/2. So we have 3 of these negative 1/2s multiplied together. Now if you multiply 3 negatives together, you're still going to get a negative. In the numerator, 1 times 1 times 1 is 1. And in the denominator, 2 times 2 times 2 is 8. Okay, so what we just found out here is this negative 1/2, that whole thing raised to the third power, is equal to negative 1/8. Okay, so rewriting everything else here, we have 3/4. We're going to go ahead and take away 9 over 16, then divide this by 15 over 8. And then we just found out that this negative 1/2, that quantity cubed, is equal to negative 1/8. So we're going to add a negative 1/8. Okay, give that a hug and put it in parentheses. Okay, so next we have the subtraction, we have division, and we have addition. Between those 3, division is going to take priority here. So we have this 9 over 16, and we're dividing this by 15 over 8. Keep in mind that when we're dividing fractions, we should rewrite this as a multiplication problem. So it's going to be 9 over 16 multiplied by 8 over 15. Okay, at this point you can cross cancel. So 8 and 16 can simplify down to being 1/2. And a 9 and 15 can both be divisible by 3. That's their GCF. So we're going to get 3 and 5. Okay, if we go ahead and multiply 3 times 1 on top, 3 over here multiplied by 1, that's going to be 3. And on the bottom, 2 times 5 is going to be equal to 10. So we're going to get 3/10 here. That's what 9/16 divided by this 15 over 8 is equal to. That's equal to 3/10. Okay, so let's go back and substitute that in. So we have 3/4 take away, and we found out this is equal to 3/10. We're going to kind of write 3/10 plus this negative 1/8. Okay, so at this point we have a subtraction problem and addition problem, and those are equally important operations. So we're just going to go from left to right here. And so we're subtracting fractions. So let's go ahead and just take this subtraction problem and move it over to the right. When we're subtracting, we do need common denominators. I think they meet at 20 for the first time. So really, I'm just going to go ahead and multiply this one by 5 and multiply this one by 5 to get 20, and multiply this one by 2 and 2 to get 20. So if we go ahead and do that, this is going to be 15 over 20 minus 6 over 20. Again, I just rewrote here the subtraction problem, but with common denominators. I used 20 as their LCD. 15 take away 6 is going to equal 9, so this is going to equal 9 over 20. Okay, so we can go ahead and write over here that this is going to be 9/20, and then we're going to go ahead and add this negative 1/8 to it. Okay, so adding a negative fraction. All right, so unfortunately we're adding fractions again and we need common denominators. This 20 and this 8 are not the same denominator, so when do they meet for the first time? Well, it happens to be 40, so you can go ahead and pause and think about that if you need to, but we're gonna multiply this one by 2 and 2 to get 40, and we can multiply this fraction by 5 over 5 to get 40. Okay, so rewriting this fraction would be 18 over 40, adding a negative, and then this would be negative 5 over 40. Okay, so again, we just took this addition problem and rewrote it over here, but this time with common denominators, and 40 is the LCD. Now we can go ahead and add the numerators here, 18 plus negative 5, that equals 13. And so this really comes down to being 13 over 40. So this final addition problem of 9/20 adding a negative 1/8 is equal to positive 13/40. That would be the value of this expression. For number 6, we have another expression, but this time we are dealing with a different type of rational numbers. We have decimals here. So we have the quotient of 1.6 and 2 minus 4 times the quantity of 2.8 minus 3.1 plus the product of 2 and 0.7, or 7/10. Okay, so I do see 2 sets of parentheses. This one actually does represent a grouping symbol. This one over here does not. This one just shows that we are multiplying 2 times 0.7, and we're using parentheses for multiplication since we have a decimal. Okay, so let's go ahead and focus over here on the actual grouping symbol, and let's take care of this 2.8 minus 3.1. Okay, so 2.8 minus 3.1, well, 3.1 minus 2.8 is 0.3, but if you're taking away 3.1 from 2.8, it's going to be negative 0.3. So if you need to pause to think and write that out, feel free to do so, but I'm just going to go ahead and write 1.6 divided by 2 minus 4 times, this is going to be negative 0.3, and then we're going to go ahead and add 2 times this 0.7. At this point, we have division, subtraction, multiplication, addition, and multiplication. And division and multiplication are equally important operations, so we're just going to go from left to right here. Now, if we take this 1.6 and divide by 2, well, 16 divided by 2 is equal to 8, so 1.6 divided by 2 is just going to be 0.8, or 8/10. Then we're going to go ahead and just rewrite the rest of this, so it's going to be minus 4 multiplied by this negative 0.3. And then we're going to go ahead and add 2 times this 0.7. Okay, so next we have two multiplication problems. Let's do the one that is to the left here first. So let's copy down this 0.8. And then if we know 4 times 3 is equal to 12, then 4 times this 0.3 is just going to be 1.2. So we're going to go ahead and subtract a negative 1.2 just because we have a positive 4 multiplied by a negative 0.3. And then we're going to go ahead and add 2 times this 0.7. We have one more multiplication problem to take care of here. That's 2 times this 0.7. Now, if 2 times 7 is 14, then 2 times 0.7 is going to be 1.4. Okay. Right now, I'm actually going to also take care of this over here. So subtracting a negative is also adding a positive. So I'm going to write 0.8 and then plus 1.2. Again, that's just a little simpler. And then plus, now let's actually add or actually multiply rather this 2 and 0.7. So 2 times 0.7 we just said a moment ago was 1.4. Okay, so this is a lot nicer looking. It's just all addition. Let's go ahead and just add these first two. Those one work out nicely. 0.8 plus 1.2 is going to be 2.0. I'm just going to write 2.0 to keep the decimals consistent. And then if we go ahead and add 2.0 plus 1.4, or 2 adding 1 and 4/10, that's going to be a total of 3.4, or 3 and 4/10. Okay, so it looks like in this scenario, you're going to be starting off this week and your bank account is going to be at $48.51. You have a debit card, which you can access your bank account's money in there, and you're gonna go ahead and be making some purchases and buying things. You can actually go below $0 when you have this debit card. There's only a catch there where you're going to have to pay a $5 charge to your account. So it's kind of like a little penalty there. And so when you go below 0 for the first time, you're gonna have to pay that $5 charge. And then each time you make a new purchase when you're under $0, you're gonna have to pay another $5 fee. So you'll be able to buy the things you want, but you're going to have to pay a $5 fee each time you go below 0 and each time after that, as long as you're still below 0. Okay, so now you know kind of like the back story or the back information that we need to get started. Let's take a look at a scenario here and take a look at an expression we can write. So in scenario 1 here, it looks like you're going to receive a $10 allowance, so that's good for you. You're going to be making $10, okay? And then that's for completing all your chores, okay? Then after that, it looks like you're going to go and buy 3 packs of the same candy, and this candy is going to cost $3.58 each. And then you're also going to go and buy 3 of the same drinks, and each of these are going to cost $2.29 each. Now, what we're asked to do here is we are going to write a numerical expression that represents the final balance, so how much is in your bank account at the very end, and then we're going to go ahead and evaluate or solve it, showing one step at a time, so making sure we're being very systematical here. All right, now remember that we already have $48.51 at the beginning, so that's going to be positive, and that's going to be at the very beginning of our problem. So $48.51 is what we're starting with. Now it looks like in this scenario, you're going to be getting a $10 allowance, so that means you're making money. So I'm going to go ahead and add 10. I'm going to put 10.00 just to keep things consistent here. And then it looks like you go to the store and then you're going to buy 3 packs of the same candy. So if we're buying things, we're going to be spending money. So we're going to subtract. We're going to take this 3 and multiply that by how much each of the candies cost. So each of the packs of candy looks like it's $3.58. So we're going to go ahead and say this is going to be 3.58. Okay. Now, besides buying these candies, we're also buying 3 of the same drink, and these are going to be $2.29 each. So if you're buying these as well, you're going to subtract, because you're spending money, it's going to be 3 times this 2.29 or $2.29. Okay, so this expression here would tell you how much money you have left in your account or your final balance. So this would be our numerical expression, okay? And then we're gonna go ahead and solve this now, okay? So what we can do here is we will start with multiplication before anything else. So we go ahead and take this 3 times 3.58. So let's go ahead and do that on the side here. So 3.58 multiplied by 3. Let's see here, 8 times 3 is 24, carry the 2. 5 times 3 is 15, plus 2 is 17, carry the 1. 3 times 3 is 9, plus 1 is 10. So it's gonna be $10.74. That's how much we're spending here on all of the candy. So that's gonna be, that's right, $48.51 plus $10. And we're spending this $10.74. And then we're also going to be buying 3 of these drinks that are $2.29 each. Okay, so we're gonna have to go ahead and multiply this next here. And so if we take this 3 times 2.29, so it's $2.29 for 1 drink, but we're buying 3 of them. Let's go ahead and say that's 9 times 3 is 27, carry the 2. 2 times 3 is 6, plus 2 is 8. 3 times 2 is going to be 6, so this is going to be $6.87. So we had $48.51 to start. We got $10 for allowance for doing our chores. We spent $10.74 for the snacks or the candy, and it looks like we spent $6.87 on drinks. Okay, so now we're just going to go from left to right because we have addition and subtraction. So if we take the money we had and add on the $10 we got from doing chores, $48.51 plus $10 is going to be $58.51. And then we're going to go ahead and take away $10.74 and take away $6.87. Okay, so this is how much money we really had before we went and bought some food. And so we're gonna go ahead and subtract this to figure out how much we had after we bought candy. So let's go ahead and take this $58.51 and subtract this $10.74. Okay, so let's see here. We're gonna have to borrow a little bit. So this 8 is gonna become a 7, this 5 is gonna become a 14, and this 1 is gonna become 11. So 11 minus 4 is going to be 7, 14 minus 7 is 7, 7 minus 0 is 7, and 5 minus 1 is 4. So looks like after buying the candy, you're gonna have $47.77, but then you're gonna go ahead and buy some drinks, so we're gonna subtract $6.87. Okay, so let's go ahead and do one more subtraction problem here. So we have $47.77. We're gonna go ahead and take away this $6.87. All right, so 7 minus 7 is 0. Looks like we need to do some borrowing again. So from the 7 become a 6. This 7 is really 17 now. 17 minus 8 is 9. And then 6 minus 6 is 0, and 4 just comes on down. So it looks like when we go ahead and buy these 3 drinks at the end, we're going to end up with this $40.90 at the very end. So the problem asked to write a numerical expression, and this numerical expression right here represented the situation pretty well. And this 40.90 at the very end here let us know that the final balance of the account is going to be at $40.90. Another way you could have written this expression, but might have been a little bit trickier to understand or maybe think of, is because you're buying 3 of the candies and 3 of the drinks, you could go ahead and add the 2 amounts of money you had to begin with together and take away 3 times this 3.58 plus this 2.29. So if you add the cost of the snacks and the drinks together here, you could add them together and then multiply that by 3, and that might save you a little bit of time as well. So this expression would have been also valid if you wanted to try this as well. Let's check out a different scenario now. So in scenario 2, it looks like you're going to be getting a $15 allowance this time, so more than before. And then you're going to be going to the store and you're going to buy 12 packs of the same candy. So you're buying a lot more candy this time, maybe some bigger packs. They're also going to be $6.38 each, so maybe they're a lot bigger. And then we're going to go ahead and buy 8 of the same drinks, okay? And these are going to cost $2.49 each. So just like before, we're going to go ahead and write a numerical expression that represents the final balance or how much money is left in your account. And then we're going to go ahead and evaluate it or solve it, showing one step at a time to see what is left in this account. All right, so we're going to start off with that 48.51 that we had at the very beginning in our bank account. Because we are getting a $15 allowance, we're going to go ahead and add $15 to this account. That's money that we're making. And then we're going to go ahead and start buying some things. So we're going to buy 12 packs of the same candy, and they are $6.38 each. So let's go ahead and subtract. We're going to subtract 12 of these $6.38 bags of candy. And then we're going to also be buying more things, 8 of these same drinks that cost $2.49. So if we're buying things, we're going to go ahead and subtract. And that's going to be 8 multiplied by this 2.49. Okay, so let's go ahead and deal with multiplication first, as that's more important than addition or subtraction. So we have 12 times this 6.38. So let's go ahead and do that. So we're going to take 6.38 on the side, 6.38, and multiply that by 12. Again, feel free to pause to do this, or if you can do it faster, great. I'm just going to try to be as detailed as possible. 2 times 8 is 16, carry the 1. 2 times 3 is 6 plus 1 is 7. 2 times 6 is going to be 12. Next, we have 1 times 8 is 8. 1 times 3 is 3. 1 times 6 is 6. If we go ahead and add these two together, we have 6. 7 plus 8 is 15, carry the 1. 1 plus 2 is 3, plus 3 is 6, and 1 plus 6 is 7. We need 2 decimal places. So 6.38 times 12, basically we're buying 12 of these packs of candy, is going to cost $76.56. So let's go ahead and take this $48.51 that we initially had, plus the $15 allowance. Take away all the money we spent on candy. Looks like it's a lot of candy. It's $76.56 worth. And then we still have to take away this these 8 drinks that we bought as well. Okay, so let's go ahead and figure out the cost of these 8 drinks now. So let's go ahead and do 8 times this 2.49. So on the side, let's take 2.49 and multiply that by 8. So 9 times 8, that's going to be 72, carry the 7. 8 times 4 is 32, plus 7 is 39, carry the 3. 8 times 2 is 16, plus 3 is going to be 19. So it's going to be $19.92. So we had $48.51. All right, and then we added $15 from allowance. We spent $76.56 on candy, and then we spent $19.92 for our drinks. Okay, so let's go ahead and now go from left to right, since we have just addition and subtraction. So this $48.51 adding $15, that's going to be, let's see, $48.51. If we add, let's see, add 10 and then add 5, I guess I can do. That's going to be $63.51, $63.51. Feel free to pause and write that out if you need to. We're going to take away $76.56 for the candy, and then take away $19.92 for the drinks. Okay, so left to right in order here, we're going to take $63.51 minus $76.56. So if we go ahead and do that, we're going to go into the negatives, right? So $76.56. So let's see, if you can't do that, we can just reverse this and take $76.56 and take away $63.51. Okay, and then we just got to make this answer negative. So that's going to be 6 minus 1 is 5. 5 minus 5 is 0, 6 minus 3 is 3, and 7 minus 6 is 1. So it's going to be 1305. So it's going to be negative 1305. Okay, and it's important to know that it's negative here, because that means we're going to accrue a fee here, right? A $5 fee, because we went negative. But let's talk more about that in just a moment. So we're going to take away this $19.92. Okay, so keep in mind that we can also say this is adding the opposite. So this is adding another negative here, right? So if that's easier to understand, we're just basically adding 2 negative values now. So we can just add their absolute value. So this 1992, if we go ahead and add that to the 1305, then we're going to see here 2 plus 5 is 7, 9 plus 0 is 9, 9 plus 3 is 12, carry the 1, 1 plus 1 plus 1 is 3. So it looks like over here, when we add the negative 1305 with the negative 1992, that's money. We are below 0. That's going to be a total of negative 32.97. Now, because it looks like we went into the negatives over here one time, and then it looks like we went to the even further below zero, that means that we have to pay a fee of $5 on 2 different occasions. So it looks like we have to multiply $5 times 2 twice in this scenario. So we have to go ahead and multiply. You could do -5 -5, or we can say you're subtracting 2 of these 5s at the very end. Because the bank is going to charge you because you went below zero. So we're subtracting 2 of these 5s. So we're going to go ahead and subtract 2 of these 5s at the end. Hopefully this makes sense because 2 5s here is going to be $10. So we're going to be at -32.97, but we're going to take away $10. But taking away $10 is the same thing as adding -$10, right? So if we add this -32.97 plus -10, that should just be -42.97. So we were asked to write a numerical expression representing your final balance. And that would be this expression right over here. Keep in mind that we needed to find out about the 2 times we went below zero and went even further below zero to know that we had that $5 charge twice. So we had to go back and put that in. And this -42.97 at the end lets us know that the final balance for this account in scenario 2 is going to be -$42.97. Alrighty, so we have one final question here. This question is basically asking, did we have to pay any of these penalty charges in the bank in scenario 1 or in scenario 2? So in scenario 1, we said no, so we can say not in scenario 1. But what about scenario 2? We can say yes, right? Yes in scenario 2. We kind of just answered this next part. It says, if so, state which scenario. So the scenario is going to be scenario number 2. Clearly, we went into the negatives over there. It says what caused the penalty charge. So for the first one, so there were really 2 charges, right? So the first one, the first charge we incurred, that was when we bought the candy, right? We can go ahead and say buying the candy. The candy cost more than what we actually had, so that's what caused us to pay a penalty. And then the second time was when you bought the drinks, right? So buying the drinks when you were already below zero, that's what caused the second one to occur. So that's what's going to cause these 2 penalty charges of $5 each. 5 plus 5 is 10, so we pay $10 in penalties. Alrighty, so there you have a few different practice problems on dealing with numerical expressions, or really just math sentences dealing with numbers and symbols. No variables or anything yet. Those are called variable expressions that we will get into in the future. But basically, we are following the order of operations, where grouping symbols take priority, and then you deal with powers or exponents, and then multiplication or division, whichever one you see first from left to right, and finally ending with addition or subtraction. Hopefully these application word problems over here were helpful in kind of seeing this in maybe a more realistic scenario, and you were able to kind of understand the different pieces and why you might multiply first before adding or subtracting. So if you found this video helpful, please consider giving it a thumbs up, and as always, keep up the great work that you're already doing, and I'll see you in the next one.